see.
I think you can go for it, Andrew.
Okay, let's let's see. Can you see the presentation?
Yes.
Okay. Yeah, good. That's, I guess, step one, right? Make sure everyone can see it. Okay, my name's Andrew. I work with George primarily. My background's in kind of software and computer science and all that. So I work as a programmer. And what I've been working on for the last couple of months is this tool called epiworld-forecasts. And essentially, it's a tool to create automatic disease forecasts, and it uses the epiworld-R package. Though it doesn't necessarily have to. We'll get to that. But that's what we're using at the moment. And so as I go through, I don't actually have a ton of slides. I don't expect to be talking for a crazy long time because I'm hoping that after I present it, maybe we'll get some questions about how it works, and then also be useful to get some feedback too if there's things that this sparks for you of something that you think would be useful or that this is missing, or, anything along those lines. I would be happy and interested to discuss it. Also, you're welcome to jump in and ask questions as we go. So don't feel like you have to save everything to the end. I know sometimes I forget my questions if I do that. So anyway, with that, so here is kind of like when you're building a forecast, these are typical steps that you're going to follow. You've got to gather some data that you're going to use as sort of a basis to calibrate a model. Then you're going to use those calibrated models to make your forecast, to predict what you think will come. And then you'll create some sort of report, maybe draw some figures, and you'll publish that somewhere. And what epiworld-forecast is trying to do here is basically provide you some scaffolding to automate these steps and to make it so, so that way you can do these things without having to necessarily run them yourself every single time. You build it once and then it runs automatically for you. So here are the technologies that we're using for epiworld-forecasts, kind of the 5 core technologies. And I'll talk a little bit about each one as if you don't know anything about them. If you do, I apologize. And hopefully I don't say anything blasphemous, but Docker is kind of one of the base technologies we're using. And for those who don't know what Docker is, Docker allows you essentially to run, you can think of it as like an isolated computer or isolated operating system. So it could be a Windows computer or Linux or something. But you run it isolated, and the only programs you give it are the programs you need for your code to run. So in our case, it's all of our R packages that we need to do our forecasts. It might be, maybe the whole tidyverse or something along these lines. You could put other things in there. What this allows you to do is run a sort of self-contained program. And so you don't have to worry that if I give this to George to run, that he has the wrong version of a particular package or doesn't have a package installed. He can just run this Docker container and it will always run the same. And then this is also useful when you're running something automatically. We're often running that from the cloud. And then you make sure that you develop in one environment, you publish it, it always runs the exact same. And then if you need to update something like versions, you just rebuild this what they call a container, a Docker container. Okay, so then the next thing we're using is the epiworld-R package. So George has done a lot of work on this. Since I've joined Foresight, I joined back in September. I've been involved a lot as well with this epiworld library, and the core library is in C++, and it does really fast agent-based models for disease simulations with just thousands of agents and just really, really complicated, runs them really, really quickly. We use the R package, which essentially wraps that C++ library. And we use this to both calibrate our model as well as to actually run the model we use for our forecast. Then we use GitHub to host our source code and our website. And so we host the website on GitHub Pages. We use Quarto, which is a tool that allows us to render the HTML website, essentially. And it allows you to write basically in Markdown and embed our code and text and all of these things and craft what you want that to look like. And then it produces an HTML website. And then we use GitHub Actions, which obviously live in GitHub, but they're their own feature, allows us to schedule our forecast, allows us to run it. And then also we use that for building our Docker image. So these are kind of the core technologies that go into making this forecast work. All right, so with that, I'm going to talk through we have an example. So we've built this tool out as a template repository, so you can essentially just copy the repository code on GitHub and get started. But we have an example to show it all in action. So we're going to talk through what we've decided to do is basically a COVID-19 case count forecast for the next 14 days for all of Utah. And I'm going to preface this, try not to get too hung up on our actual forecast because that isn't our background. And we've been focusing more on the tool itself. So there might be, there's probably a lot of assumptions we're going to be making here as far as the forecasts that aren't necessarily the best. But the point is that we can do all of this automatically. So you could update the forecast to be better. So what we do is in the first step, the gather data. So Utah DHS publishes kind of updated COVID-19 case counts for Utah every week. They do it on Wednesdays. And this data is pretty historical. I think it goes all the way back to March 2020. And there's actually a lot of data in the data set that is published here. We're using the simple just COVID case counts for Utah. But the first step in our pipeline is to grab that data. And then we use that data to calibrate our model. So we make an SIR connected model, and we use likelihood-free Markov chain Monte Carlo. And both of these are features of the epiworldR package. We're using LFMCMC to calibrate an SIR model. And essentially what we're doing here is we're basically running an SIR model for 90 days, so like a 90-day model. And we're trying to get it to reflect the most recent 90 days from our observed data in the previous step. So we run an SIR model for 90 days. We compare the case counts that this model gives us. How close is it to the observed case counts? And then we tweak the parameters of the model and we run it again. And we do this 6,000 times. And this all happens very fast because of the epiworldR package, that we can run these 6,000 iterations automatically. And it's trying to sort of step the parameters towards something that will produce case counts that look like the observed data. Once we have a certain, several thousand of those that we accept because they're close enough, and we like that these models are working, these parameter sets, then we are going to run our forecast. So we select 200 of the best runs, essentially 200 of the best model runs that were that mapped to that observed data, and we run them an additional 14 days. So we originally run them 90 days to map to the observed data. Now we're running 14 days forward as our forecast. And then that becomes a forecast distribution. These 200 different models running give us a mean forecast, give us confidence intervals, et cetera. So then having run all of those, we use ggplot to our package as well as Quarto. We create some figures. We make a little HTML report, which describes the forecast, describes our methodology for it. And then we publish that on GitHub pages. And so all of this automated with GitHub Actions, all of these steps happening every week for the last couple of months. And as we make little tweaks to maybe how the forecast works, or we make some tweaks to what the report looks like, or how we handle our data. But you can send those updates in code, and then the forecast just automatically updates itself every week. Okay, any questions so far?
So Andrew, go ahead, Yue. Go ahead.
Oh, sorry. So the forecasting work is largely based on the SIR model, right? So not some
What's that?
time series forecasting approach.
No, not necessarily. This is just an SIR model calibrated with LFMCMC.
Got it. Okay.
Yeah.
So is there so I know we choose the SIR model because we want to use the epiworld, but beyond that, is there any other reason we go with the SIR model?
That isn't my expertise. I don't know. George can tell you. epiworldR has a lot of different models in it. So I'm not entirely sure from like the science of epi and stuff why this model is the best. But George, maybe you could speak to that.
Yeah, we just picked that as a starting point. But the model it's a little bit more complex than we're mentioning here, because we do have, for instance, different contact rates as a function of the day of the week. We have different transmission rates as a function of the time, particularly looking at seasons. So that way it's an SIR model, but it has a handful of like other layers that make it more complex. But to go to the point, as Andrew mentioned, we just pick that to start, but you can pick anything. So you can have a time series model, something even written in Python. Python, I think, will still work for this. The point is that we have this template repository framework that you can use for automating the forecasting process.
Yeah. So I should have mentioned the kinds of parameters that the LFMCMC is modifying are like recovery rate, transmission rates for different seasons, contact rates for the day of the week. I'm trying to think if there's anything else. I think I said recovery rate. So those are the kind of parameters that the LFMCMC is tweaking and testing. But you could expand that list. We've tried different ones. You know. Yeah.
The model calibration model part could be go any model, right? Could be IR, SEIR, or even go to statistical time series model, anything.
Yes. Yeah, it could be any kind of model. Yeah.
Yeah. Okay.
So we were kind of going for a simple one that we could, well, relatively simple that we could get moving. Yeah.
Yeah.
Any other questions before I move? Kelly, did you want to say something? I don't know.
Oh, sorry. I was going to ask a question and then I took a peek at the report and answered my question. So you can proceed.
Oh, okay. Okay, so I wanted to give some example figures. I'll actually show you the final web page, so we don't have to dwell on these too much. You can see the forecast isn't necessarily the best, but you can see on the right the forecast that we produce, which is the observed case counts in black and then the distribution of the forecast in blue. And then the left is the different parameters that were tested during the LFMCMC process. So LFMCMC starts with the vertical bar on the left for each of those graphs is like the starting value, the initial value. And then LFMCMC is going to step that value forward or back or whatever, up and down, and try different things. And that's kind of the distribution of what it tested. And again, this is just an example of something you might output in your own report. One for the forecast, one more for the methodology. Okay, so obviously the goal of this tool is for you to be able to use this for your own forecasts. And to that end, essentially there's 4 files that you would need to modify to adapt to your own needs. There's the forecast files, there's 2 of those, and then there's kind of automation files. And the forecast files are going to require heavier changes. So forecast.r is the R file that holds all the business logic. So this is loading all the libraries, doing your calibration, running the forecast. All of that happens here in one file. We've separated up by different commented sections so that it's easy to kind of know where to put your changes or your code. The goal of this file is that you can run it without producing any visualizations, that the code just runs the forecast, but it gives you these 4 visualization functions. And the purpose of that is to kind of separate the like logic of the forecast from then the actual kind of product, which is the second file, the index QMD file, which is a Quarto file. It's markdown. And what this does is it essentially grabs the functions and runs the forecast, like sources the forecast.r file, and then it grabs the visualization functions and it adds those and along with text and everything else to produce the web page. And so that separates the 2. You have one for actually displaying and rendering your forecast and one for running it. And that allows also for development, you can run the R file separate and just run it as an R function and test it a little more quickly than rendering a whole website. So those files will probably require heavy modification unless you're just planning to take our example and try to make it better. You're going to be adding a very different forecast, maybe a different model, maybe different calibration steps, different sort of text for your report. But the automation files should largely be mostly unchanged. I mean, you can still make tweaks to them. So the run forecast YAML file is the GitHub action workflow. This is where it defines the schedule. It sets up all the GitHub actions, the automation steps to do this. And so you'll probably modify the schedule. You might modify whether or not it publishes or where it publishes to. You could have it, instead of publishing a website, you might have it just produce a CSV that you can download. It could do that in this. And this is the file where you define what it's going to do. And then the Docker file where you would add your libraries that your code needs and define your Docker image. Okay, so if you have does anyone have questions about these? Then we're going to go and look at the actual website that we produce and look a little bit at the code. Does anyone have questions though about these files before we move on?
I wasn't able to speak before, couldn't turn the microphone on. This is Zai Kurbik. I'm from VA with Kelly. SIR models are notoriously prone to overfitting. So you have several calibration methodologies. How are you getting around it? So how should I it might not be very clear as a question, but SIRs can fit to almost anything that you want it to fit, even with less components. You're talking about 200 parameters that you could calibrate on. How are you controlling this? How do you make it reliable?
So again, George maybe can speak more to this. As far as I know, we're not doing as much trying to make the forecast necessarily really good. It's really just an example of calibrating generically. And the point would be that you could then use the tools around it to then do a more robust forecast yourself. But I don't know, George, if you want to say more to that.
Yeah, so that's a fair point. So just a clarification, it's not that we have 200 parameters, but rather what we do is that we take samples from the calibration process, which is an MCMC-based calibration. We take 200 samples out of it, but we are just calibrating, I think it's like a 5 or 6 parameters, so it's not that many. Yeah, and SIRs may be overfitting, but again, so we are not like focused as much just yet on the actual model. Eventually, we do have a couple of other models that we are going to be using with this. We have a project that's called epiworld-R Calibrate that uses recurrent neural networks for calibration. And then we have another project that we haven't started on, but that's more focused on the actual forecast itself, like using machine learning to correct from the let's say structural or like observed biases that you have from your SIR model or whatnot. But yeah, but again, just to reiterate, all of those can be adapted as a function of whatever the user needs. So if you have other calibration method that you prefer, you can plug it in here. You'll have the infrastructure to do so.
Thank you.
Any other questions? Thanks for that. And then, okay. So this is my contact. If you want to email me, we're going to jump over and look at the actual website for a minute. And I'll share the slides as well. So here's what our example report is. Like this is what we produce every week. Again, it's hard not to get distracted by our forecast, but that isn't really the point of this. The point of this is more to show what you could be doing for your own forecasts, for your own needs. So essentially, this is it. This is just the forecast. It gives a little introduction of what we're doing, publishes what we think, what our forecast is, our intervals. We have additionally provided like a page for our methodology where we describe how we gather the case counts and how we calibrate, and these are the different parameters that we're testing, and here's the results of LFMCMC, and includes all of these details, but these aren't necessarily required. This is more to showcase that, at a base level, you just need one web page that produces a forecast, but you could add additional web pages and build this whole thing, make it a little more complicated. You could run multiple forecasts on the same, and publish them all on different pages, whatever you need. Again, the tool is flexible for that. So then looking really quickly, and this is the last thing, and then it'll be, I guess, time for feedback and questions and everything else, is this is the repository itself. So it lives under the epi4site group and called epiworld-forecasts. And the README basically gives a lot of the same information I've already given you. You'll see many of the same charts that we just talked about from the presentation. But then down here, it talks about each of those 4 files again and links to them so that you can kind of find what you need and take a look. So can everyone read this okay? Is it too small? Do I need to make it bigger?
I think it's okay.
All right. Okay. So this is like the example of the Docker file. So we start with tidyverse. So the R tidyverse, that gets us Quarto, gets us base R, obviously, it gets us ggplot, and then we're adding epiworld-R as kind of an additional package here. And so you would just add a run, install, and then you'd install the other R packages that you needed. And that's how you'd modify your Docker. And then when you build this image, all of those packages are now loaded in, just as if you had downloaded them to your computer. And then the other file I wanted to take a quick look at here is this is the workflow file for the GitHub Actions. And the key bit here is the schedule. So this is where you decide how often it runs and what triggers it. So ours is set to run at 6 a.m. every Thursday. This uses POSIX cron time syntax. So it's basically, I think it's like, I forget what the first 0 is, but this is like, hour, and then you've got day of the month of the year, and then kind of day of the week. So ours is 4th day of the week, Thursdays. And that's because the DHHS does data set updates on Wednesday. And then the rest of this defines, uploading the website, for example, and deploying it. And then also, I guess we can look here. This is the Quarto file. So this is what renders our main page of our website. the key line is that it sources that forecast.r and runs it, but then it just uses the plot function. So the forecast has already been run in the background, and then you just have to plot, and then obviously include any text or links or anything else that you'd like. And then the last file is this forecast.r file, which is the big one. And we've tried to delineate sections. Again, you could do whatever you want with this file, really. But we try to delineate sections to make it a little easier for just, if you only wanted to change certain components and didn't want to change everything. But I imagine that for most forecasts, you'd be changing the majority of that file. And that's it. That's the epiworld-forecast tool. So we really hope that that you'll be able to find some use in this, that you might be able to use this scaffolding to run your own automations and make, again, it's a template repository, so you essentially can just copy the repo and then modify just those specific files that you need to create your own forecasts, and probably much better ones than we've done, obviously. And yeah. So with that, I guess I'm done with the presentation, but I guess I want to know, if you have questions we can talk about, or if you have any feedback of things that you think would be more useful with the tool, things I didn't understand. Yeah, thanks.
Thank you, Andrew. It's a very interesting talk. So I have a naive question. Do you have like a parallel forecasting option in your second step? For example, if we want to try different model and simultaneously, especially statistical model, I know in your SIR model, it's a epiworld package very fast. But if we, in the same way, we can incorporate some other forecasting model, which kind of a little bit time consuming, and we want to do it in a parallel way. In the current pipeline or in your workflow, is there a way to do it parallelly?
I believe so. Yeah. Our current workflow doesn't. It just runs linearly. But yeah, that would be that's a possible change you can make.
That would be great. Yeah, I think that would be good to add some more module in your step 2. Like there's an SIR IP word-based module, and we can have another statistical forecasting module, or even machine learning AI module for the forecasting work. I think that would be wonderful. Yeah.
Yeah.
Yeah, just to add to that, if you guys didn't got it, the nice thing about GitHub Actions is that it's free computing time. So we're not using any servers of our own, anything. So we just have this GitHub repository that uses a virtual machine that is hosted by Microsoft. And you can, I think, I don't know how many hours you have by monthly to run it, to use it, but I never run out of time. And you can have a model that fits, I don't know, it takes an hour to fit and run it there, and I think it'll be fine. So you can have multiple stuff running simultaneously, leveraging this open source stuff. So I think that's why I'm excited about this.
Yeah. And I mean, the one we showed where we run like the 6,000 LFMCMC iterations and then the 200 forecast iterations, that all takes like 2 or 3 minutes for this one. I mean, ours example is intended to be lightweight, intended to be simple and straightforward. But yeah, because it's also running up there on the cloud, running on the Google resource or the Microsoft resources, you don't have to really worry as much about those things. But yeah, all of those kind of tweaks are doable. Pilar, I think you have your hand raised.
Yeah, kind of partially answer my question with the last comment, but I was wondering how efficient it was, because I'm working on a Shiny app, and one of the problems we have is, well, it's different because it has to process a lot of images and raster images because they're maps that get updated, but that is very intensive computationally, and so it's just there's a lag. So it's a Shiny app, so it's not just a report, but there's a lag in the use. So we were kind of working on making it more efficient, but yeah, wondering if you have any thoughts on that.
Well, I don't know entirely how your like project set up, but or how to use Shiny with this kind of like setup, but I don't know if it's the kind of thing you could separate too. You could have like the image processing almost in one place and then run the Shiny app separate, so it isn't trying to do both at the same time.
Yeah, I think that's what we're doing, but we might reach out to all of you, your team, to maybe try to figure it out.
as a quick note on that, in other projects that we have had like similar issues, like with a big computing time, we use a lot of caching. So for instance, you may have some maps that may need like rastering or whatnot, but many times all of those computations can be done once, and you can just save the results. We have done that in the past. There's alternatives. We have done it on GitHub Actions as well. So instead of like having to run everything all over again, you run it once. So the first time it might take you whatever much time it takes, but then you save the results. So in the next run, instead of like rerunning the computations, you just like preload the results. That could be like an alternative.
And then also with that, you can have multiple workflows that trigger different times. So we have, for example, the main forecast workflow, which triggers weekly. It also triggers every time I update the code. So if I go and change the code, it will run it again. It knows, that. But then for the Docker container that we're using, that only changes anytime we make changes to the Docker file specifically. So it doesn't update scheduled. It doesn't do any. It just, if I change that file, then it goes and updates. So you can also have multiple workflows doing different things as well and combine them. Yeah. Jose, you had a question or hand raised?
I do, but before I get into that, Pilar, making it run on the Shiny is not really efficient. As they said, if you make the engine separate, run it and spit out the results and show that not continuous result update, that would continue. I mean, amazing. This update, speed up the process. Regarding my question, is there a way to introduce, or may I suggest you to introduce what if scenarios? So you could have, yes, prediction is important. However, what if scenarios are extremely important and much more reliable and easy way to go and say, hey, I'm increasing vaccination rate to this, or I'm making a health announcement to increase hand wash, thus lower the transmission rate, kind of scenarios. And you could run those with some sensitivities. Is there a way to do that, or would you consider to do that? Thanks.
So do you mean to do this interactively, where the user goes into the website and makes changes and then it updates? Or do you mean just including those scenarios in the, here's our forecast and here's what we would do with the following scenarios?
Either way, actually, both of them. I'm coming from the epidemiological, like I'm coming from use case, right? I'm coming from, hey, you're introducing me a model and you're making predictions. Give me the tools to modify it, and now I, even if the predictions are not reliable, it will tell me what will change and how much, and I can make decisions on which direction to go in that sense.
Yeah. I mean, so the one option of just adding in those additional scenarios to the GitHub, or to the existing report, that's not very difficult. You're just adding essentially additional forecasting steps. Here's our forecast. Here's it with these different scenarios. That's fairly straightforward with the given structure as it is. As far as doing something automatic interactive, I'm not entirely sure how to make this interactive from that sense. It might be more likely that you just have to like rerun the code and then push it back up. Like I said, this updates every time you change the code. So that's like my current knowledge, but I'd have to look into more how to do because the updates you're sounds almost more like a Shiny app of making tweaks and then seeing changes in the results.
It doesn't have to have visualization. Well, the visualization is the key, but if you can pull out the parameters and say that if you wiggle this, if you play with this, this is your, say, vaccination rate, this is your contraction rate, this is your school opening, closing, or scenarios. So if I can, you can use the Shiny app as an interface if you like, but I don't need to see the results right away. I'm trying to see the end result. I can't wait for it.
So we do, we actually already have we change the contact rate based on the weekend. So the model has one contact rate, but we have it built in the example. that it updates whether it's a weekend or a weekday. So, and the transmission rate also. So yes, that's actually something you can build in pretty well to adjusting your different parameters to account for a different intervention or a different time or a different event. Yeah, that's something that's definitely within the scope of it.
Yeah, the reason I'm saying is you might not be, well, predictions are hard, but modification of like using a simulation to be helpful with the interventions is quite useful. It's one of the good ways to use a model.
Yeah.
Thanks.
Quick note on that. Again, it's we do have another package that's currently doing that. epiworld-R Shiny. It's the Shiny version of epiworld that allows you to kind of like build that kind of tooling. We have pre-built in models that allow you to like play with some parameters and run scenarios. And we have an active project around it for missiles. So we're going to be building something specifically for missiles that has a Shiny app around it that the users can go ahead and play with it and see like what if scenarios.
Yeah. Okay. Any other, I guess, questions or comments? Gripes, moans, personal beefs? Yeah.
So in your forecasting, you have 14-day forecasting now. Are you doing like a one-step forecasting for up to 14 days, or you just simultaneously forecast 14 days?
Wait, I don't know if I quite understand. Say that again?
So essentially, you have 14 days forecast in your output, right, currently?
Yeah.
One way we can do is we can do forecast one day and use that forecast one day as input and refeed the model, make another forecast for the second day and sequentially up to 14 days. And another way to do, at least statistically, we can do like we can build model for 1 day forecasting, 2 day forecasting, 3 day forecasting, and then simultaneously give 14 outcome. We don't have to do doesn't rely on the sequential dependence. So in your current, I just want to clarify whether you use the sequential.
Yeah, our current example essentially just runs 200 models for 14 days. Is essentially what it's doing. So it fits the model to the last 90 days of data, and then runs it, just keeps running it for another 14 days, essentially.
Okay, so it's like a sequential approach, right? Okay.
Yeah, yeah. Okay. And then it just runs, and then it runs a bunch of those. Yeah.
Got it. And your current confidence interval is based on the 200 repeat.
Yes. Okay. Yeah, basically the spread of those 200. Yeah. But this is cool because these are the kinds of things that we want to make the tool available for modifying. Is that if you had a better, more robust approach to the actual forecasting, bam, you could do that. And
I think your step 2 can be play around by different approach, different procedure a lot. Yeah, but I overall like the procedure.
Yeah. My hand is still up. May I ask you one more question?
Sure. Yeah.
How is this possible? Let's say you created a prediction and a day passed and new data came in. How do you introduce the new data and compare it with your prediction and update your prediction? Is there a way to go with that, like day by day update? And so will it create? So the way you say it, it will rerun 200 days from scratch. But I want to use it like a Bayesian approach and see the last iterations to guide the coming iterations.
Yeah, so I can conceive of a couple ways that this could support that. Because as you're saying, at the moment, it essentially just takes the newest data, takes the last 90-day window, does the whole thing from scratch. So 2 ways that come to mind. One is you can set up a workflow to save files and then grab them later. And so one way to do it is to just grab the last run of the forecast and use that data, save some sort of useful data for yourself of what you would need to compare, and then do that. And then the other way, and this is perhaps like, maybe this isn't as useful, but one way to do it is like the way this runs, we use like, random seeds and things to make sure that every time you run the forecast for that given data set, it will always produce the same output. So another option would be to run it on, like the previous, like basically just run it twice, run it for like one window back, if that makes sense, and do that all within the workflow file as it is. So it would basically runs the forecast, the new from scratch forecast for the last 90 days, but it also runs the forecast for the 90 days minus a week or something, and then compares the output. You could do both. But I mean, those are the two that come to mind. There might be more complicated ways of doing it, but yeah, but that's definitely something you could add to this.
Yeah, and I think you're saying it right. So ultimately, you can store the data and do like an evaluation of the quality of your forecast, and then use that, for instance, for correcting the forecast. So in other words, so learning how I am at forecasting, I can improve myself, right? So but that's part of the other project that I was mentioning. So we do have a project that uses machine learning with mechanistic models to improve forecasts in a way to introduce, to make corrections based on the type of error that the forecast usually makes, right? Because again, it could be that this AR is like overfitting or doing some other weird things. We can train a machine learning algorithm, which we have done in the past for some other projects, to learn what are the usual errors that it makes, and then use that information to make corrections after building the forecast. So, yeah.
Thank you.
Awesome.
I have more of just a comment, if that's okay.
Go for
Real
it.
quick. Because Andrew, I love this. I think that it's a really good framework to steal from, to take that scaffolding, as you said. We're always cautious here at the state with sending things to other servers or like the cloud to run data. And so we'll have to look at our data and our security. They're very cautious with this stuff. Even with publicly available data, they get very concerned with sending data up to the cloud to run. So, but I just want to say I love this approach and this idea, and would love to try and work it into what we're doing for some automation.
Great. And I guess a quick as well to that, I haven't done this myself much, but I'm pretty sure there's a way to modify the same automation tools to run on your own servers or machines. And so you could set it up to run, for example, here there's like the CHPC clusters and things, and it wouldn't use a GitHub Actions workflow, but sometimes the workflow files look very similar. And depending on what your systems can run on. Yeah. Oh, and self-hosted runners. Yeah, I haven't used those as well. Thank you, Kelly. That's a good point as well. So you can also do self-hosted. So it's GitHub Actions, but running on self-hosted. But then there's other ways of also using the same thing and just automating in different ways. So there might be a good solution for you to look into that way as well. Oh, and George is saying it's not that complex. So he's done it, I think, or at least knows how to do it.
I've worked with it. Not that I've done it personally, but so it doesn't seem to be overly complicated. You can set up a machine, a server that connects to GitHub, and GitHub has like a script that you can run in that machine, and it will set it up for you. So that way, when you're running, you can say runs on, I don't know, like DHHS machine, and it will like use that directly without having to pass through their servers. So. And again, I was saying CFA does it. They have a bunch of like self-hosted runners, and they have like protected data that runs on their servers through GitHub Actions, which is pretty cool.
Yeah. And then also related to that is, I know sometimes, I don't know if it was, I think someone at UDH just also mentioned to me that there's some wariness to putting forecasts up online without enough explanation. And so that's, again, something else you can modify to just to save it for personal use, just for your team or something like that.
Well, thank you so much, Andrew, for presenting today. This was super interesting, and thanks everyone for contributing to this discussion. I'm glad that Rand and you spoke up since you're one of our partners, and we're glad to have you here.